चालू केला
So again okay, sequence. Next test.
De-Alembert test.
Scientist. It's like a theorem without proof. Statement. Let summation xn be a positive series positive term series, terms are positive, so that limit of xn plus 1 upon xn ratio, D'Alembert ratio test you can say, D'Alembert ratio test, ratio this one, okay, this one, depend on this is L, n is suppose limit L, then first series converges if this limit here is less than 1, series diverges if limit here is greater than 1, and third test fail if L equals to 1. So this test fail means apply any other test. Okay, using this test we cannot check converges or diverges. Okay, if L equals to 1, limit will be 1, then okay. Okay, like previous test we have so many tests. Okay, so without proof, okay, this test. So examples on this D'Alembert ratio test. So test the convergent of the series. First series summation nq plus a divided by 2 raised to power n plus a be 1 plus 3 upon 2 factorial 5 upon 3 factorial 7 upon 4 factorial and so on respective factorials. See 1 plus x upon 2 x square upon 5 x cube upon 10 and so on. Given to you here also general term also x raised to power n is n square plus 1 also given to you here general term. So test now this. So first question में given series summation xn that equals to nq plus a divided by 2 raised to power n plus a. So therefore xn nth term will be nq plus a upon 2 raised to power n plus a. I want n plus 1 in the series, so x n plus 1 term will be in case of n plus 1 cube plus a 2 raised to power n plus 1 plus a. Okay. So these are positive terms. Yes, these are positive terms are all the natural numbers. Therefore, I want their ratio xn plus 1 upon xn, and then their limits ratio. So first we find the ratio. So ratio n plus 1 cube plus a upon this means so 2 raised to power n into 2 plus a divided by xn original n cube plus a upon 2 raised to power n plus a. So which is same as, okay, xn plus 1 cube plus a upon 2 times 2 raised to power n plus a, cross multiply 2 raised to power n plus a here and n cube plus a here. Now, okay, so I think highest power, so n common means n cube common here, 1 plus 1 by n cube a upon n cube first term. Here 2 raised to power n common, 1 plus a upon 2 raised to power n. Here 2 raised to power n common, 2 plus a upon 2 raised to power n. Here n cube common. Okay, so highest power common, remember, because limit is n tends to infinity. Therefore, I want 1 upon infinity. That is 0. So all terms I want 1 upon. And this like term must be cancelled. Otherwise, infinity answer. Okay, so highest power common. Now limits. Okay, simply right. So this is xn plus 1 upon xn ratio. Now limit of this, limit n tends to infinity. Also limit of this, limit n tends to infinity. So limit of each term. Okay, so limit of each terms. Now apply. N tends to infinity. So 1 plus 1 by infinity 0. This one a by infinity 0. 1 by infinity 0. 2 plus 1 by infinity 0. 1 plus 1 by infinity 0. So only 1 by 2. 1 by 2. So 1 by 2 less than 1. Okay, so limit of this will be less than 1. Okay, so less than 1 means what? Okay, converges. Therefore, by D-Edinburgh test, okay, given series is okay, converges. Okay, so this first example. One by 1 factorial, 2 by 2 factorial, sorry, 3 by 5 by 3 factorial, say 1 by 4 factorial and so on. Okay, so see the general term now. This okay, xn will be okay. 1, 3, 5, 7 odd numbers are odd numbers starting from 1. That is twice n minus 1. Starting from 1, twice n minus 1. Starting from 3, twice n plus 1. 1 factorial, 2 factorial, 3 factorial, 4 factorial. What is there? N factorial. This is your xn. So of course positive or all the natural numbers have a series of positive terms. Then xn plus 1. So in place of n plus 1. In place of n plus 1. We simplify twice n. 2 minus 1 plus 1. N plus 1 factorial means what? N factorial into n plus 1. Now their ratio xn plus 1 upon xn. So twice n plus 1 divided by n factorial into n plus 1 upon original twice n minus 1 upon n factorial. Or this is same as twice n plus 1 divided by n factorial into n plus 1 cross multiply with opposite n factorial and twice n minus 1 here. So n factorial cancel. Okay, now check limit. After simplify limits limit of okay this ratio. So limit of this n tends to infinity. So twice n plus 1 divided by n plus 1 into twice n minus 1. So same technique, when n tends to infinity then always highest power common. Otherwise infinity, no answer. If you apply rightly n tends to infinity, no answer. Okay. So take highest power common. So from here highest power is n common. So 2 plus 1 by n. Okay. Also here common n. 1 plus 1 by n. Also here n common. 2 minus 1 by n. So 1 n cancel only, 1 n extra remaining. Now apply n tends to infinity. Okay, so 2 plus 0, 1 plus 0. But here infinity, n is infinity, 1 infinity, 1 n extra, all n cancel. All n will be cancelled, remember. Okay, so 1 n is extra here. So 1 by infinity, 0. 0 less than 1. 0 is less than 1. So less than 1 again same. Okay, convergent. So given series is convergent by the ratio test. Third. One x by 2 x square by 5 x cube by 10 and so on. General term also given to you, x raised to power n upon n square plus 1 and so on. So given to your general term xn, n term will be general term x raised to power n divided by n square plus 1. Positive terms are all the natural numbers. I want x n plus 1 in place of n plus 1 in place of n plus 1. This is same as x raised to power n and x raised to power 1. This same. Now ratio xn plus 1 upon xn, ratio will be x times x raised to power n divided by n plus 1 whole square plus 1 upon original x raised to power n upon n square plus 1. This is same as x raised to power n divided by n plus 1 square plus 1 cross opposite n square plus 1 divided by x raised to power n. Now limit also limit here. So limit n tends to infinity of this term only x. Again here same technique, highest power common. Okay, n square plus 1. So n square common, 1 plus 1 by n square. Also here n common is n square common out of square, 1 plus 1 by n whole square plus 1 by n square. Okay, so now n square cancel. And now apply the limits. N tends to infinity. X remains same. N tends to infinity. So bracket 1 plus 1 by 0. 1 by infinity 0. 1 plus 0. 0. So only all is only x. Okay, depend on the x. But what is x not given to you? You have to the choice. Chances. X chances. Okay, 3 chances. Depend on the x. So if x is less than 1, okay, x is less than 1 and after 0, less than 0, then limit of this xn plus 1 divided by xn, this ratio will be x. X means what? Okay, less than 1. Limit will be less than 1. So less than 1 converges. This is converges. Second chance, x is greater than 1. Greater than 1. Limit on the x greater than 1 series. Okay, converges. Now, if x equal to 1, x equal to 1, limit will be 1, then test fail. Test fail. So this test fail. So apply any other test to check the limit. Now, so as your xn is what? X raised to power n divided by n square plus 1. Now here x equals to 1. X equals to 1. This will be 1 upon n square plus 1. Your xn will be 1 upon n square plus 1. So apply any test. We have previous test. Comparison test. Okay. So this is nearly equals to 1 upon n square. This suppose say y n. Okay, 1 upon n square will be nearly equals to 1 upon n square. N will be negligible. Fractional. So this will be nearly equals to yn. Now this yn, summation yn 1 upon n square series. Okay. So p equal to 2. P equal to n raised to power p. P equal to 2. Greater than 1. So p greater than 1. Then converges. Series. Okay. Converges. Yn series converges. Therefore xn series converges. Solution xn series is also converges. So when x equals to 1 will be converges. Okay. Therefore given series is converges when x is less than 1 and equal to 1. But positive x must be positive term series. So x is less than 1, first chance, and equal to 1, and diverges if x is greater than 1. Okay, so these examples. But ratio test. Ratio check xn plus 1 upon xn. It's ratio check. Limits. Next test is a Cauchy root test. Cauchy roots. So clearly root of some term. First see test examples. Theorem again without proofs. Let summation an now in place of xn n running from 1 to infinity be a sequence of real numbers. Sequence of the real numbers such that limit of nth root of an, limit of n root test root nth root of test. Of course, n test infinity will be real. Suppose here all an term must be positive, or all the natural number every an term must be positive terms. Okay, then same category series converges if n is less than 1. Second series diverges if n is greater than 1, and test fail if n is equal to 1. So three possibilities, same as the Dilbert test, but here nth root of an. Nth root of an. Now see examples. Same question, test convergent or divergent. Test the convergence of the series. Okay, problems 1 to problem 1. So summation n running from 2 onward. Here not possible, 1 onward. See problem 1 upon. Okay, ln log of n. Log of n raised to power n. Next, summation n upon n plus 1 raised to power n square. So take these two problems. So see two problems. So first question, okay, summation xn or an will be summation n running from 2 onward. 1 upon log of n whole square raised to power n. 2 onward, because log 1 there, log 1 is 0 and 1 by 0 infinity. Okay, that's right. So therefore your an term will be 1 upon log of n raised to power n is positive, yes, for all the natural number after 2. Okay, all the natural number n after 2, not 1, because n equal to 1, log 1 is 0. So after 2, this is 2. Okay, positive. Now by root test, therefore, so nth root of am, nth root of am. Continue. So am is 1 by log of n raised to power n, same as 1 upon log of n whole raised to power m, 1 raised to power n. So right side n power, this left side 1 by n power, n raised to power 1 by n power, the nth root of. So 1 upon log of n, 1 by n. So now limit n tends to infinity. 1 by n power means nth root of am. 1 by n power. So nth root of am by test it is 1 upon log of n. Limit n tends to infinity of 1 upon log of n. So 1 upon log n, log infinity, 1 by infinity 0, 0 less than 1. Okay. This is less than 1. Okay. Therefore, by test given series, okay, convergent. Less than 1 converges, greater than 1 diverges. This first question. Now second, B part. So summation an. Now here no problem. 1 onward is n upon n square plus 1 and n square. So therefore an will be n upon n square plus 1 raised to power n. N upon not n square plus 1, only n plus 1. Only n plus 1. So this is same as n upon n plus 1 raised to power n and raised to power n. N square, n into n. So remove 1 here, raised to power n means here, left side, raised to power 1 by n upon n plus 1 raised to power n. And here n common, 1 plus 1 by n raised to power n cancel. It is same as 1 upon 1 plus n, 1 by n and raised to power n. Okay, now limit n tends to infinity of an raised to power 1 by n. Also limit right side, limit n tends to infinity of 1 upon 1 plus 1 by n raised to power n. So 1 by infinity, 1 by, this is enough limit here also. Standard limit, that is a e, 1 plus 1 by raised to power n, that is a e limit. 1 by e less than 1, e is 2.71 control value. So 1 upon 2.71 fraction less than 1. Okay, therefore carbon convergence. So series is convergent. Okay, so less than 1. So both the problems are less than 1.